Hello everyone, how's it going? Welcome to another episode of the Stray Basilisk Coding from Scratch stream. This is Jason. We're back here again. I think we're on episode 12 now of this, and today we're making a... Okay, so the topic we voted for on Twitter was Fireflies, so we're going to do something cool with Fireflies. Exactly what that's going to look like, I guess we'll figure out as we go along. Hello, Lorzinho. How's it going, buddy? Can you let me know as well if you're seeing like dropped frames? So I checked the VOD for the previous stream and it was real bad. Like there were some issues with the internet or something because it was coming across like super janky. So I don't know what I can do if that happens again, but if you could let me know. Yeah, I'm doing good. Doing pretty good. So it's a bit of a late start today, but I'm kind of excited to be doing this one. I'll try and keep it relatively short and sweet today as well. I'm thinking it'll be quite simple, but that's always kind of famous last words with this kind of thing. Okay, so what I'm kind of aiming to do here is to take some kind of scene, like I feel like a forest scene makes sense for Fireflies. I've gone on opengameart.org and I've found these two asset packs, which I think we can use one of these as a basis. And what I effectively want to do with that is to... Well, my internet must be kind of slow, this won't load. What I want to do with that is to take one of these scenes and kind of have little fireflies glowing and flying in and out of these trees and out of these layers in a kind of natural fashion. So for folks who played Steamhounds, we have this forest stage, which is very much like this. So I'm going to effectively show you how that kind of stage is put together with all the different layers and the firefly effects and stuff. Yeah, so the first thing is to figure out what kind of backdrop we want to use. This one's super cool. It's made by a guy called Anzimos, who has a Patreon. I'm pretty sure I've come across them before. They have some really cool kind of pixel art asset packs and stuff. So I definitely suggest looking them up. The other one here, I like this one because there are more layers to it, right? I believe this one is, 2 layers. Whereas this other one here is like 5 or 6 layers. So I think this may be more interesting and have more depth and more of like a 3D effect to work with. So I think to start with, I'm going to go with this one here. I guess I need to download all of these separately. It also looks like this is just a little square section, so we may have to do some like tiling ourselves to make it a bit wider so it fills the screen up a bit more. Okay, so here's an example of kind of how it will look when it's all put together. Yeah, it looks like this tiles nicely like repeats like this. So we can make something happen here with this, I think. So we've got all these individual pieces, which I'm going to now open up in an image editor. Okay, there's one. There's 2. There's 3. There's 4. I think we've got one more. Yep. Cool. So hopefully we can... Yeah, right, like it's going to be atmospheric and spooky, I think. It'll kind of go with the music. I think it's got a kind of spooky vibe to it. So there's two main elements to this. Maybe 3. So the first one is how we actually compose the scene itself with these terrain pieces. The next part is how we have the fireflies like move around, and this will actually relate back to some of the previous streams with like the bird flocking stuff, even the solar system gravity simulation we did, because if you think about it, that kind of sweeping kind of rounded movement is kind of similar to what we saw in that solar system like gravity simulation, and that's kind of how I would like the fireflies to move as well. And then the last part is how we actually draw the fireflies, so they kind of have like a cycling on and off pattern to them, and also we want to probably do some kind of lighting effect in there as well. So I'm thinking we can layer these up in this way. So let's bring up that reference again and we can try to recreate this. Okay, that looks kind of the same to me. The only difference is because these are like tiling, we could move any of these layers. It looks like the same in terms of the height of the ground and all of that kind of thing, but it's just been like scrolled a bit kind of left to right, so we'll be able to do that as well. I think rather than dealing with writing code to do all the tiling, I am just gonna kind of assemble everything like in the image editor, and then it should all sort itself out. We can just import them. It's just like 5 layers. So probably take this whole group. How wide do we want this to be? First of all, I think I'm going to scale it up by... So this is like 1x, you see 100% down here. Maybe something like this, like 4x, that seems reasonable to me. Let's just pick something and go with it. So 400%. As always, when you're scaling pixel art, you want to make sure exactly how this is named will depend on your image editor, but you want to turn off interpolation or smoothing or whatever they'll call it. If we use the kind of default here, we'll get this horrible blurified pixel art. I'm sure the artist would not be pleased with, so instead we're just going to turn that off, and pretty much any image editor will let you do this, and then we'll keep the crispness of these pixels intact. Now I want this to be wider, so I've just found out in this GIMP editor I can just say like 480 times 6 and it will do that for me, which is extremely convenient. So let's just move these across, make sure they line up. Is that right? Okay. Do that a couple more times. I can tell it should be 480 pixels. There we go. So in terms of having this on a window on the screen, this may be enough. So because of parallax, the kind of near layer is going to shift back and forth more, whereas the back layer is going to be more static. So what, maybe I will throw a couple more of these on. Stick to my original plan of having 6 copies. Now, if I was doing this in a serious project, I wouldn't have done this. I'd have done this in code because I'm kind of wastefully loading in an image that's basically 6 times bigger than it has to be. But just for convenience of getting something there, you know, computers are beefy and powerful these days. They can handle like a 3000 pixel image. That's not a huge deal. So now what I want to do is to isolate these layers as well. So let's first of all just export our background. So I've created this Fireflies folder. We're using processing for this again, by the way, and that will expect all of this stuff to be in a data folder. So I think I'm going to call this call it layer 0. Be a good programmer, start counting from 0. It's our next layer. Layer 1. Layer 2. Hello, Take 20. How's it going? Appreciate you stopping by. I'm also kind of a big nerd and a D&D fan, so props for the screen name there. Okay, so here's our top layer. Yeah, okay, let's get straight into the code and load this in and do some funky parallax stuff, because I think that will be fun to do. So, this is processing. Check previous streams if you're not super familiar. I find myself explaining the basics of this every time, so I'm going to kind of speed ahead maybe and get this real basic stuff up and running. But I'll still try and vaguely explain what's happening as I go. Awesome, you too. Hope everyone has a great weekend. It's looking kind of grey out there, but it's better than the crazy heat wave we've had the last couple of weeks, so I appreciate that. A bit of respite. Okay, we've got to kind of load all of this stuff into this. I've just got an array of layers here. So in fact, I can kind of populate this array in quite a succinct way by saying I could probably have done this in a loop, but a bit of copy and pasting over being fancy isn't always a terrible idea. So I was debating internally, should layer 0 be like the back file layer or the front layer? And because we kind of want to draw the back layer first and then draw everything on top of it, that's kind of... I'm saying that's my reasoning for this ordering, but honestly it was kind of arbitrary there. Yeah, so we need to be able to draw these things. So we just implement this draw function, just kind of where all your update and drawing happens. So how do we do this? Kind of all we need to do is... Well, something major I forgot is the very first thing in the setup should be defining the size of our window. So we know that this thing is 480 pixels high, and we probably want to start with like a reasonable like slice of it. We want to kind of window into this, right? We don't want to have the full width of this because we want room to like pan left and right with our kind of virtual camera, if you like. So maybe something like that. Actually, I'll choose something that'll fit on stream properly. So yeah, maybe 1200 pixels by 480 seems like a good starting point. So in terms of getting this parallax to work, there's two ways I can do this. I can kind of do it the manual way, and then I could actually, okay, so the manual way would be something like just kind of having these images like drawn on top of each other, like essentially in a 2D sense, but just kind of manually offsetting them left or right based on our like camera position, right? So maybe if the camera's 100 pixels to the right, then the closest layer will also be 100 pixels shifted, but the layer behind will be shifted less and less and less until we get to the back layer, which is not shifted at all. or shifted only a tiny bit. We could do that, or we could actually create these things like in a more real like 3D scene where they're actually positioned into the distance, and then OpenGL, or the graphics card, will actually handle this all for us. Obviously on the old consoles this was done this way, right? Like on the Genesis or the SNES or Mega Drive, as our spirits call the Genesis, that was the way of doing things because they didn't really have 3D processors. But what I kind of think would be cool later on is if we could start from like the front view and then just like pan the camera out so we can see the 3D structure of the scene. I think that'd be a cool little visual for us to kind of understand what's going on. So I think I'm gonna do that. Also, I'd like to have the Fireflies be able to move kind of in 3D a bit more truly, which would get kind of awkward to handle with this setup. So I think I'm going to use the power of our modern gaming machines to kind of do this for me. So I'm just going to loop over all these layers. Then we need to draw these things. So I think I'm gonna assume for now these are like equally spaced, but I'm gonna kind of define some basic parameters up here, and maybe we can make these tweakable. Let's say max plane depth. Like the scaling factor of these we can figure out later. I think maybe I'll just use the basic pixels as something there, so that probably means 100 won't quite cut it, they'll be super close together. So I don't know, it's like say 1,000. And then what I'm going to do is figure out how far in the distance this plane will be. So if the first one is at 0 and the furthest one is at 1,000 right now, we kind of want to divide it up equally. And the way we can do that is to say, if this is plane... You know what, I've just realized I'm actually... The first one we draw is the far plane, so... Let's say... Okay, this gets a bit janky. I'm actually gonna... Oh, I feel horrible doing this. I'm gonna... No, I won't allow myself, okay. I was gonna reorder them, but since I've named them this way, it kind of makes sense that they're that way in the array. So layer 0 is going to be at that far distance, and then layer 4 is going to be at 0. So we kind of want to do something like this. Looks kind of ugly. I was trying to get away from writing up this ugly expression. But if we think about this, okay, so all this is dividing 1,000 by however many planes there are, right? So there are 5 things in here, so that we'll have 200. This will be 200, which it makes sense. That's the kind of steps we want. So we want the near plane at like 0, and then 200, 400, 600. 2, 4, 6, 8. Okay, I've run into what's called the fence post problem, where there are 5 things, which means there are 4 gaps between them. Okay, so actually this should be like 250. This should be 500. This should be 750. This should be 1,000. So the steps are actually not by dividing by 5, but dividing by length minus 1, so dividing that into 4, or if we had 10 layers, it would be dividing it into 9, because there are 9 like increments between that. So that's just our kind of step size, and this is just to get it so that when we start at 0, then we're at the right kind of multiple. So if this is 0, then the length is 5 minus I plus 1. So 5 minus 1 is 4. So we'll get 4 times 250 equals 1000. And if we're at the very closest layer, then I will be 4. So I plus 1 is 5. The length is 5. 5 minus 5 is 0. 0 times this is 0. That's all that's doing there. Now we want to draw our image. Since we're kind of doing this in 3D, probably the easiest way is to do... Actually, we'll image. Let us draw an image with XYZ. Let's have a look. Bring up the trusty processing reference. So, image function, displaying an image. Okay, so we can put X and Y width and height. So actually to draw this in 3D space, it is going to have an issue. So probably what we want to do is use some of the more fancy functions where effectively we draw it at 0, 0, you know, at the kind of origin, but then we use other functions to like shift it around in 3D space, which gives us more flexibility. This is how, if you want to get really fancy with rotating and scaling and positioning images in 3D, you need to kind of do something like this. So without getting too deep into the weeds, all this is doing here is we're going to do this moving and rotating, but we want it to apply to only this particular layer we're drawing. And this is kind of like a save and restore for all of that rotation and scaling information. So under the hood, it's using some matrix-based math, which can get super hairy, and we don't actually have to really deal with it, but effectively that's all it's doing, is it's like kind of saving and restoring, and then in the middle we're going to do all of our fancy translating this thing around. So for now, let's draw it at 0, 0 depth. I kind of like to indent things inside here, so it's clear that this little block is the stuff that this is applying to. And now we draw the image. So we pull out the current image from the array, and we just draw it 0, 0 all the time. Okay, another thing we probably want to do is, I feel like throughout this whole thing, we always want to draw images based on their center position of the image. By default, they're drawn based on the kind of top left corner. But it makes more sense to think of these central position, I think. So things probably won't look quite right here, but we can sort this out. Okay, so the issue essentially is that 0, 0 here is still like the top left corner of our window. So we probably actually want to do width over 2, height over 2. Okay, there's our basic thing here. It doesn't look quite right to me. Let's try and figure out what's happening. So which layer are we seeing right now? Okay, I think what we're seeing is like zoomed in on some little section of this. So the problem is that by default, when you draw 3D graphics, it uses what's called a perspective projection, which means that we have our little camera or eye, however you want to think of it, and then we have our plane set up. In fact, one of them's like right butting up against it. Different distances like this. We have our 5 equally spaced things, but the point of view of the camera is kind of like this, which means it's seeing essentially it's really close to this first plane, so we're seeing a really zoomed in little section. And that's why probably, that's my guess for why we're seeing this kind of slightly distorted, unclear thing going on here. The way around this is to use something called orthographic projection, which is like more like you'd see in like so a perspective projection kind of looks like this, right, where things get smaller off into the distance, whereas an orthographic is more like these kind of diagrams which aren't quite true to how we actually see things, because this back face of this cube should be smaller than the front one from our perspective, but with orthographic projection that's not the case, and the way that does that is rather than having this cone of vision, kind of has this just like block of vision, which is, not really a real thing. Maybe you can do some crazy stuff with lenses to get something similar to that, but this is how like architectural diagrams and stuff are normally drawn. And that's kind of what we want here, because we always want these things to appear the same pixel size on screen, if that makes sense. So I should probably look up, actually in processing, how we do orthographic projection. Have a handy ortho function. Yeah, look, there's a diagram which kind of gives us a hint of that. So you can just call ortho. Yeah, all objects with the same dimension appear the same size, regardless of whether they're near or far from the camera. So that's what we want here. We set that up at the beginning. Okay, that looks a bit better. We're definitely seeing this one layer, but we are also seeing a load of grey behind it. Why is that? Let's check in here that our stuff is all exported properly. So one possible issue is that another thing you often have to specify in this sort of setup is what the like maximum view distance is. So there'll be some kind of cutoff where you're not seeing stuff. So maybe it's the case that, and often it's a range, right? Like a minimum and a maximum range. So stuff which is super close to the camera you often can't see either. So there's only a certain active range, and maybe that just doesn't encompass all of our stuff here. So most likely there are parameters here, yeah, for what we can see. So we're kind of going to need to set this up manually. Nope, still doesn't like that. Okay, what can we... How can we kind of debug what's happening? So... You have a think here of what we might be seeing going wrong. So I think we're not having an issue with transparency, which can sometimes be an issue here because it looks like we're still seeing the background color. If I change it to black, yeah, we can still see the background there. Throw on the debugger and step through here to make sure we're not doing anything crazy with the positions. variable window up there. So the first one is at depth 1000. That seems correct to me. $500, 250, 0. I wonder if we're getting like a something flip back to front. Okay, that looks better to me. So I think the issue was we had stuff translated actually behind the camera. Like this. So the thing at 0 we were seeing, but you know, the first one, but the other ones were actually offset in the wrong direction. So kind of want to account for that. Also, I don't think we're seeing the very furthest one because it's right on that like maximum depth. So I'm just going to extend the view range of our camera to make sure it definitely encompasses that one. Boom. Okay, there is our basic scene. So, hello, Fluffy. How's it going? So we want to be able to move left and right here, right? So, good. Always glad to hear that. So, I'm going to call this camera X. I'm just going to do something where... You know what, maybe we can just determine this by the mouse, right? So, camera X equals... So if we have our little window, and if our mouse is right at the left-hand side, we kind of want to have this panned all the way left, and if it's at the right-hand side, we want it panned all the way right, so I can just kind of move the mouse and have it shift side to side. It feels like a nice way to control this. I'm doing good. Feeling pretty good today. So I think there's a handy function in processing which will do something whereby I can say, hey, I want to take the mouse X, which I know starts at 0 and goes up to the width of the window, and I want to now map this to some other kind of offset. So I know that my window size was 1200, but our big old wide image is kind of bigger than that. So effectively what we're doing is we're going to have a 1200 wide thing here, which will start like that. And maybe we want to allow it to move left by whatever that sort of range is. So let's say 700. You know, it doesn't need to be exactly aligned with this, but that seems reasonable. So what this map function will do is we'll say when mouse X is at 0, we want it to be minus 700, and if it's at the width, we want it to be positive 700. That should do that nicely for us there. And now I can just take yeah. In fact, if the camera's moved one way, the object should kind of move the other, I think. I often get these mixed back to front. Some things I don't bother thinking too hard about because I can just run it and then flip the sign around. It's probably a bad habit, but yeah. So what we're making is we've got this cool scene right now. Whoa. Okay, something's going weird. So we've got this cool scene and I want to have fireflies kind of moving, glowing, flashing on and off, and like flying around this scene and in between the trees and stuff. So I'm doing something weird here. Okay. We also want that cool like parallax scrolling effect going on. Oh, okay, so I don't need to offset the Y. I don't know why I did that. Okay. So, okay, so we're now kind of panning across our scene. That's all good, but what we're not seeing is the parallax effects. Yeah, so they'll... Yeah, so I think we'll kind of get to the glowing shortly, in fact, but if this is like a graph, right, I kind of want each firefly to like maybe have like a regular thing like this. But then, you know, if we have another firefly, they don't necessarily all need to be in sync, right? So you might have another one which is kind of glowing like this. So it will kind of appear random, but each one will just be on like a regular cycle. Playing around with this for Steamhounds, for like the forest scene in Steamhounds, the way we've done it is we've got a few different groups which are like synced up. So there's like 3 or 4 groups of fireflies, so there'll be a load of them, you know, with this same pattern, and then there'll be other ones which are like offset like this, and it creates a nice thing where you have like different clusters which will sometimes go in sync and kind of go in and out of sync, and it feels quite natural. But yeah, that's the whole deal that we kind of want to achieve. So I kind of misspoke earlier where I said that using this 3D arrangement will actually handle the parallax for us because we're using orthographic projection. That's no longer the case, right? If the camera moves down here, then our window of view is now just another thing, but everything's still like aligned in lockstep. So what we will need to do still is to offset the X position of stuff according to how deep it is. So let's just say, have I spelled parallax correctly? I don't care. It's going to be let's say parallax intensity equals you know what, one way we can just do this is say we can just divide this by some number we've already got here. So we already know the depth, and we also know when I is 0, we're talking about the furthest thing, and when I is high, we're talking about the closest thing. So I'm just going to say the offset is going to be equal to the camera x multiplied by something like I divided by, try something like this. I'm sure there's an actual formula here. Okay, it did not like that. What am I doing wrong? Not 100% on it, it seems, today. We shall see what's happening here, though. Fix that. Parallax offset is 0. That makes sense for this one. Parallax offset is coming to 0 again. Okay, what's happening here is, this is kind of a subtle thing if you're new to programming. So these are both integers, right? So we have these floating point things, which are, you know, things with decimals in them. If you want to write a floating point that doesn't have a decimal, you put this, that's what this F on the end indicates. So 10F is equivalent, essentially, conceptually, to like 10.000. If I just say 10 though, that's a whole number. And if I is a whole number and this is a whole number, the result it gives you will also be a whole number, and it will effectively like round that down. So this will come to some fraction, but it will just get truncated down to 0. So the way around that is I can say, hey, consider this to be like a floating point number. It's looking a bit ugly. I could have probably arranged this more nicely, but that's likely what's happening here. Cool. So we are seeing some kind of parallax effect there, which is pretty nice. It is, yeah. So if you ever played old school, like 16-bit era games, this is how they did all of their fancy backgrounds. So maybe that mountain in the distance is moving a little too quickly for my liking. We can tweak that, but for now, we've got a basic framework up and running here. So that's parallax. Next is probably to draw some fireflies on here, right? So I need an image for a firefly, so I'm just gonna kind of draw something on here at what feels like the right size. And I'm not an artist, so the way I typically do this is I'll just use like a soft brush and kind of plop something down. Yeah, feels okay. Maybe I will create a copy and then apply a blur to it so it has a bit of a aura around it. Yeah, that's a firefly if I've ever seen one. Nice. I'm also doing this in white. We can tweak the colors in the code, so we can tint and make them green or whatever we want. So I'm just going to merge that layer. I'm just going to then crop that layer down, and then export this as a new image. Just call it Firefly. And close some of these tabs here. Get rid of that thing. I was about to discard this. I feel like maybe we'll need to tweak this in future, so I'll leave it for now. Okay, next thing, how do we draw a firefly, right? So I'm going to make a separate class for this, because that just seems sensible. We have a firefly. I'm going to be rough and ready and just have a global firefly image here. Be better practice probably to pass that through and store it in here, but all of the image assets in this whole thing are just going to be these layers and then the firefly most likely, so not going to get too crazily unorganized. Make sure to load that. So when we have a firefly, they're going to need to have a position. And not normally one for abbreviation, but I feel like pos is pretty acceptable here. And let's say when we create a firefly, so this is the constructor for the firefly, which kind of allows us to spawn it with certain information. We just save off whatever position we are told. And then let's just give it a draw method. And all we're going to do is similar to what we did before. Do something like this. translate this off, and then just draw an image. So, okay, so one thing is this width height thing here, which I kind of don't like. I think what I'm actually going to do is do like a global translate everything to recenter the 0 position to be the center of the screen, because that's going to be more convenient for us. Divided by 2, so now everything we do will be offset by that. So check I haven't ruined our parallax rendering there. Nope, still looks good. We probably want a list of fireflies, right, for all of this stuff. Firefly. So we're using these handy list collections. We just need to then import those. It's just a Java thing you kind of have to know. Don't worry about that too much. So let's add a firefly. Add. So you know what? I'm thinking that our closest, so right now our closest like tree line is right touching kind of right in front of the nose of the camera. We kind of want to open a bit of space for some fireflies to be in front of that. So rather than having that start at 0, I think I'm gonna have like a min plane depth. So maybe something like this to give us kind of a bit of headroom, if you like. Now I can maybe clean this ugly looking math up a little bit. So we have our depth step between layers is going to be equal to the distance between the furthest one and the closest one divided by the number of gaps, the number of steps, which is the number of layers minus 1. Okay. So now I can say the depth is going to be equal to in plane depth plus that's maybe a little bit nicer. It's kind of debatable. Cool. Come back to this in a second. Okay, everything still seems to be going as expected. So let me try shoving a firefly in front of the camera. So let's put it, so we know that our nearest tree line is 250, so let's put it right at 0, 0, the depth of like 100. Okay. Oh. Like this. So adding a new firefly to this list of fireflies and giving that firefly its initial position. So let's say So now here we're going to draw our lovely parallax layers. And after that we want to draw our fireflies. And all we need to do here is say, let's kind of loop over all the fireflies in our list, which is all this does. And for each one we're going to say, hey, draw yourself. And then when it draws itself, it just kind of shifts itself to the correct position, and then yeah, it just draws an image. Okay, so we can see our firefly there. It's kind of locked the camera. So we may actually need to apply the same parallax deal to the firefly itself. So probably it makes sense then to have use the same kind of code to calculate that parallax effect, both for the fireflies and for the layers. So given a depth, we want to kind of calculate that offset. And we're just going to use that same code here. And then rather than just using the index of the layer, we need to be able to do this for any depth, even if it's like somewhere between these layers. So let's say, oh, we can use map here again, right? So map the depth. And if it's at, so depth is kind of between is this min and max, and we want it to get 1 if it's close. So if it's on the minimum plane, then the camera movement is directly correlated to the kind of pixel position of the thing, and if it's way off in the back, then there's no effect. This may look a bit, okay, so kind of what this is doing for us is saying, if we have this graph, right, where, oh, where did my nice colors go? Where if this is the depth, and then this is like the parallax amount, or how much the camera movement affects the position of the object, then if we're at the position of the minimum plane, it's going to be like 100%. If it's 0%, so this is like the minimum plane, or the first tree line, and this is the maximum, which is way off in the distance. Then if it's close, then it'll be 100. If it's maximum, it will be 0. It's possible though for fireflies to be actually closer than that minimum line. So I believe all the map function will do is it will kind of extend this like this. So if things get really close, then they'll kind of move off to the side of our camera, which I think is fine, and nothing's going to be like beyond this, so we don't need to worry about that. Things would start shifting the other direction, which is not really correct, but this should work. So, say calculate parallax offset, camera X, depth. Maybe do this in a separate variable. Still doubting the number of L's in parallax. So what we need to do here is just return. Okay. Hopefully this does what we want it to. Please. Yep, those all seem good. let's now have the Firefly use the same thing, right? So action.x plus, again, we're going to use the exact same deal here. Depth is just Z, we have that already. Okay, and hopefully we'll get something sensible here. Cool, yeah, so in terms of our visual intuition, it seems like that Firefly is a bit closer to us than the trees, which kind of exactly makes sense. Cool. Of course, it won't get bigger if it's closer. We could do that as well, but I kind of feel like we don't need to worry about that too much. Awesome. So now we have a Firefly. We could, in theory, have a lot of them. So let's just do that. Add a load of Fireflies with some kind of randomness to them. Processing has some convenient random things which will give us randomness in a range. Yeah, we can say random low to high. So what's the absolute minimum something can kind of be at? It's going to be right off to the side here, right? So that's like minus. Say like minus 1500 or something. Y is going to be, we'd like it somewhere on screen and probably not like too low. That might look odd. So bearing in mind this center is the kind of center point, so up to maybe 200 and then maybe up to 300 kind of above. And then Z, let's have some of them, let's say between 0 and let's have some of them way off in the back maybe. So now we should have 100 randomly positioned Fireflies. Okay. Some of them, I'm hoping to see them being obscured by these trees. It's a bit hard to tell. Put the range way higher. Probably okay for now. So the next thing is to give these Fireflies some kind of movement behavior. So right now they just stay still. Let's think about how we want these things to move around. I feel like what we ultimately want is a kind of just like a random walk. So, you know, maybe the Firefly starts here and then it's going to fly off here and then come back. And they're going to go off somewhere else. Like, that's how Fireflies move, right? And one very simple way to get that kind of effect is to have the Firefly, so maybe it's here to begin with, have it pick like a random position. Maybe it's here. Then have it just kind of fly towards that. And then when it gets within a certain range, have it then pick another position. So maybe it's back here. And then what it will kind of do is steer itself around back here, and then maybe it decides it wants to go here. So as long as it can't turn like super sharp, which would not be nice, and it has a bit of momentum and steers itself, then this generally gives you a really nice kind of wandering, floating effect. And it's super simple to do, and you can tweak things like, you know, the speed and acceleration of this thing, which will determine how tight of a curve it can make, and also this range here. One thing which we may see happen, which you kind of want to avoid, is if you do this in a really simple way, you can reach a point where this Firefly will actually just orbit something. So that's something to be wary of. Generally, you can just set this range, like, rather than dealing with having them actually slow down to make sure they don't get kind of sucked into that orbit. If you make this range big enough, then this tends to just work itself out, and you can do it in the most simple way imaginable, really. So now, as well as these things having a position, they should also have a velocity now. Which also means we need to have an update function for these. And they also need, I'll call it like a seek pos, like a seek position, to say where they're gonna try and seek. At some point they're gonna need to pick an initial position, and when they get close enough, they're gonna need to pick a new one. So I'm gonna say, just moving this out here rather than inside the Firefly, just so there's a convenient place for all of our tweakable parameters can live. Give it a seek range. Which can be, so let's say 100. They probably also need like a max speed from experience, or they'll just get crazy fast zipping around. And if this is pixels per second, again, I'm just gonna, maybe 100's okay. You can totally tweak this. Acceleration is just gonna be how maneuverable they are. These are definitely tweakable things. So what's this logic going to look like? So if we don't have a seek position yet, or the distance between our current position and our seek position is less than that range, which is to say we're within that range, right? So this will calculate the difference in positions, and then this will measure the length of that, which is basically our distance, and then we compare that to that range. If this happens, then we need to pick a new thing to seek. Which can be as simple as, so we need to pick something again in a reasonable range. And you know what, that can be, effectively it can be this same range here, right? So let's actually add a make this a reusable thing. just use that here. And in fact here, we can just use the exact same thing. Cool, that should work for us. Now we need to accelerate towards our seek position. So how do we do that? So we kind of need to figure out, this is something we've done some version of in many streams already. So okay, so if there's our seek position and there's our kind of range there, we kind of want to, maybe our current velocity is we're going this way. We kind of need to steer ourselves towards this, and the way we do that effectively is to find this line between one and the other, and then limit it based on our kind of maximum acceleration and maneuverability, right? If we could just steer like this, then we'd just basically teleport directly to our destination, but in fact we kind of just need to limit this based on our maximum speed, whatever that may be. And what effect that will have is it will kind of, if this is our current velocity, you can imagine we're sort of adding this little line onto it. So our new velocity will be kind of in this direction, which makes sense, right? We were going like pretty straight up, and now we've like steered to the right, and over time that will kind of steer us in a thing towards this. So that's what we're doing here. Very similar thing here. That's a vector from our current position to our target, or taking the target position and subtracting our current position from it, which is kind of the same way, a different way of saying the same thing. Then we want to limit it to our maximum acceleration, and then we want to kind of add it onto our velocity, right? That's all acceleration is it's adding stuff onto velocity. So there's one thing we've missed, which is that we need to know, at this point we need to know how much time has passed since the last frame, because all of this movement and physics stuff, if it's been a second since we drew the last frame, then we're going to move further than if the game's, if this thing's running really fast at like 1,000 frames per second, then we're going to move a tiny amount each frame, so we kind of need to be conscious of that. So what I'm going to do is say something like so there's a function here, it should be an int, which tells us how many milliseconds the whole program, I keep wanting to say game, it's not really a game, it's been running for. So how much time has passed? It's the current time minus the, let's say last, if like previous is kind of a bit clearer. So when we talk about a time delta, all a delta is like an amount of change. So if it's been a second since the last frame, then the delta time, as you often hear physicsy people call it, is 1 second. So that will tell us that in milliseconds. Often when we're talking about physics, we're talking about meters per second and all of that kind of thing, so I feel like it's convenient to convert this into seconds, which is as simple as dividing this by 1,000. And then we want to remember our time this frame is kind of, next time around it's going to be the previous time, so we kind of remember that for next time. Okay, and now what we can do is we can pass that through here when we update the Fireflies. So in fact, So make sure we call that, make sure we tell it how long has elapsed so it can timescale the physics properly. Okay. So then what we want to do is we want to... Okay, what is acceleration? It's a change in our velocity. So we're just going to say... We're just going to add... multiply this by time delta seconds. Okay. I'm going to limit, enforce the max speed if you like. If so, what's the speed? If speed is greater than Firefly max speed, then I'm going to just kind of clip the speed to Firefly max speed. This is not the most efficient way to do this calculation-wise, but I very much doubt this will be an issue. So now we need to just move based on our current velocity. So what is movement? It's just taking our position and then adding our velocity to it, but not just our velocity. That also needs to be scaled by how much time has passed. So both the effect of our acceleration on our velocity and the effect of our velocity on our position are dependent on how much time has passed. Okay. Is this it? Again, this could be optimized. There are a couple of unnecessary repeated calculations here, but I want to say this is going to work. Yeah, so a few things to watch out for is whether we get this little like orbiting issue, and then we can tweak the parameters, and also just to generally tweak these parameters. In fact, what I think I'll do is processing gives us a really cool feature where we can sort of change the code in real time to kind of tune these parameters. So to do that, I kind of need to put them in the draw loop and make them not final. It's kind of messy, but it allows us to use this cool feature called tweak mode. Okay, as should maybe have been expected, we got an error here. Because we hadn't set our initial velocity. We can set it to 0. Maybe that's not quite what we actually want, but because everything's going to start from a dead stop. Well, let's take a look. Okay, these things are way slow. They're also disappearing, so I wonder what's happening there. It's to do with the depth. They're coming too close to the camera or something. In fact, I think I should have been moving in the other direction in relation to depth. Yeah, these are pretty slow. So let's use this tweak function and let's amp this up a bit. Here are our Fireflies. Here are our tweakable things. Oh, didn't run it in tweak mode. Tweak. you kind of see it's given us, these are actually little sliders, so I can push this up and they will start accelerating faster. Make it really high and they'll be probably too fast. Let's try and follow one and see where it goes. Yeah, I've definitely got something wrong with my depth clipping here. What might be nice actually is if we had a little debug view. Oh, I should maybe have kept that. It's a pretty neat feature, right? This whole tweak mode thing. Let's have an option, which I always end up doing this. Is a debug mode. Give ourselves a little toggle whenever any key is pressed. And then what I think I want to do is something like if debug mode's enabled, then I'm going to draw a line from ooh, this is interesting. A line from to basically a line from the thing's current position to the position where it wants to end up. So this should give us a little indication into the AI mind, if you like, of these little fireflies. So if I press a key, we do not see anything. What's wrong there? Maybe make sure that line has a color. Okay, I've got something wrong here. I think well, you know what? I can draw this line in 2D without issue, I think. Kind of space age, but not exactly what we hoped for, so What's going on here? Yeah, I bet I've got this offset by like the screen width and height or something. Let's just have one Firefly. So we have a better chance of figuring this out. Basically, this is because I'm kind of being a bit lax in how I'm applying all of my translations and stuff. Maybe 10. Oh, probably it's because I'm doing it inside here. Okay, there we go. I think that's a bit better. Yeah, so we can see that this little guy here is seeking a particular position, kind of floating around it. Hopefully gets close enough. There's definitely an issue with the depth or position of these things where they're kind of flying off. Yeah, so looking at this dude, he's probably got stuck into some kind of orbit. So tweak the acceleration or speed, or what I'm kind of inclined to do is actually just to let's draw a little circle to show their target location. That could definitely be bigger. Potentially quite a lot bigger. I think this factor of 2 was incorrect. Yeah, I was trying to remember if this does the radius or the diameter. I think it actually that would be correct, which means we can make this smaller. That's something I'm not accounting for in this visualization is there's like a depth, like a 3D depth as well. But to be honest, this kind of is what we need. I just need to figure out this issue with the things getting like clipped off and not visible, which we would hope would not happen. The issue may be that things are getting too close. So we're getting some of these, but not a crazy amount. Kind of floundering here. So I always forget about the orientation of the Z axis, whether it's like towards the screen or away from it. So some of this may be messed up on that account. Yeah, there's something not right in terms of how these are getting clipped off. However, I think we're at a reasonable point to take a break, so I will just throw a bunch of Fireflies up on the screen here and leave this running for a little bit, and probably be back shortly where we'll think a bit more about the rendering of the Fireflies. We'll have them glow, and we'll maybe apply some kind of cool lighting effect using them as well. Cool, I will catch you in a couple of minutes. Okay, and we are back. I've had a little snack and refilled my cup, and also I've been thinking a little bit about what this issue is that we're seeing here. I'm thinking it may be something to do with processing and the way we're loading and displaying images. So I'm going to got a couple more ideas of things we can try out to kind of debug this. So one is get rid of all of these background images. Oh, that is kind of cool, but it's not exactly what we wanted. Okay, so we're still seeing stuff here. I think the issue may be because I'm using where are we? This image function to draw things, and I'm not 100% sure if it likes that being used in 3D. Yeah. So I think what I may need to do instead is use a more manual way of drawing, if you like, which is I'm hoping they have something for drawing a quad, and they do. Okay. Okay, so we need to kind of get the coordinates of the corner, which is no problem. So x, y, x, y. Okay. How do I do a 3D primitive? Yeah, I think we may need to do something a bit more manual. So here's an example, right, where the image function is kind of something for our convenience, but here they're kind of more manually saying, hey, we're going to start drawing a shape with this texture. These are the coordinates, or these are its position in space. These are the texture coordinates. So, you know, the top left corner of it probably is the top left corner of the texture. UV coordinates, to be more specific, and then we end it. So I think it's possible, and I'm suspecting that using this regular old image function, where are we, is not behaving nicely with respect to like Z ordering stuff, and in terms of how occlusion and stuff is happening. So I was wondering if somebody's mentioned this before. The other thing is this should definitely be negative. It's going off into the distance. Actually, I've confused myself about that. Let me check again. Sometimes this is awkward to debug because it's kind of hard to visualize, 50 back or away from the screen. So we should have negative numbers in our Z translation going on. Which I believe we are here, and also for the Fireflies, yep. Okay, so let's change this to instead Firefly image. Now, since we're already using translate, I can just specify these as if it was positioned at 0, 0, if that makes sense. So I kind of just want to see what this person's doing here. So if it's the top left we're talking about, then we're looking at minus and then the top right. It's over here. And then bottom right. See if this looks any better. I may have got the ordering wrong here. Okay, did not like that. What am I doing wrong? Probably maybe need the Z coordinate in here. Also might be an issue with having to specify the points in clockwise or counterclockwise. That's kind of an issue you often have to deal with. This is weird also. Why is this 100? Guess that's up to do with tiling of this texture. So normally UV would be between 0 and 1. Maybe it's like pixel UVs. That's conceivable that they're doing something like that. Or percentage, kind of non-standard, but processing is made for kind of convenience of people new to things. So maybe if that's seen as less, yeah, okay. If that's seen as less like technical, then they'll probably do that. So this is probably like pixel space UVs, if you like. So I'm still seeing something kind of weird where these are occluding each other, meaning that sometimes one of these images passes over another, and even though they sort of, yeah, you can see an example there, like the box of it, if you like, is kind of obscuring other stuff, which should not be happening. I wonder if we have to draw them in depth order. That's conceivable as well. So this is kind of getting into some funky Java syntax. Okay, this actually looks a lot nicer now. They appear to be not occluding each other. I'm noticing something which almost certainly you can't see on the stream, which is that these are having an outline drawn. Whoa, this is crazy. So I probably need to say, in fact, with that sorting change, I bet it would have been fine to just draw the image in the normal way. See, I've been using Unity so much that I'm getting into my head that I don't need to worry about sorting things and drawing them in the right order. You put them in the right depth and it kind of handles it, but probably that's not being done for us here. And I would not be surprised if that's the issue. Yes, they're looking way better now. So I can ditch this stuff. I probably also need to have these parallax layers included in that, so this is not the kind of thing I wanted to focus on in this stream, but let's do this, whereby what we kind of need to do, rather than drawing stuff straight away, is we essentially need to build up a big list of everything we want to draw, and then sort it so that we're drawing the far away things first, and then gradually drawing the nearer and nearer stuff, and then kind of draw it all at once in one pass. And internally, this is what pretty much any rendering engine will do when you're dealing with stuff with transparent bits to it, which isn't like completely solid shapes. So so let's give this an image and a position. Let's give it a constructor. Which just takes both of these things in. Go. And then what I'm going to do here is create or I can reuse this between frames. Wouldn't be a terrible idea. Then all I'll do is clear it here. Hello, welcome back. Sorry, I didn't check chat for a minute there. I'm not sure how long you've been around. We're just fixing some glitches with kind of how these things are drawn and how they're like occluding each other, like obscuring each other. And it's requiring us to, rather than drawing stuff in like a random order, we kind of need to figure out everything we need to draw and then sort them so that we draw the far away stuff first, essentially. So what I've basically done is, rather than drawing stuff, I've made a little object which contains all the information I need to draw it, namely what the image is and where in 3D space it's getting drawn. And then I'm just adding it to a list. And then what I'll do is I will have this not actually draw, but I bet there's a built-in function in processing which I'm missing for this exact purpose, but oh well. Okay. So now the Fireflies will just kind of queue themselves up. So then what I'm going to do is sort our little draw queue. So ideas for next week's stream. So I really like the Peggle clone idea. I've had that on the Twitter poll like every time, and so far it's never won, even though I kind of think it would be cool to do. Yeah, but if anyone's got any other suggestions for totally new stuff, that kind of fluid simulation is cool. I may add that to the poll as well. Another thing I've seen is people do like sand. So rather than water, it's more like sand simulations, like pixel arty sand simulations, which are quite cool. Okay. Yeah, do you know what I'm talking about? Yeah. I bet there's I'm thinking like there's some really old school. There was a particular game way back in the day that I can't remember. Yeah, like this kind of thing. So you could kind of drop stuff and it would like pile up like this. Yeah. That's a kind of classic thing to do. VR headset. So I have the original Oculus dev kit, but that's like way obsolete now. I've never really got into any of the newer stuff. I find it hard to sit down for like too long on that kind of game, so I don't get like sickness too bad, but definitely an issue sometimes. Okay, so our Fireflies seem to be looking okay. Let's add our layers back in. Does it still work? Maybe it's like pretty low res. Like, I don't know if the modern stuff works for it. I'm sure we could get something going. Okay, this seems nicer now. So we're now seeing these Fireflies actually going behind these trees as we might expect them to. So yes, this is way better, I think. So we now have more of a sense of 3D space going on here. I kind of want to have more of them closer. So let's tweak this to be generally closer. Simple VR game. If you got an idea for what the game itself would be, then maybe. I feel like it's going to be really hard for me to get it on one monitor so people watching the stream can follow what's happening, but in principle I'm down for it. Okay, so the next thing is to make these things glow. So how do we do that? Maybe that's a good question. I think we want to have their brightness follow some kind of pattern, right? So maybe absolutely easiest way to do this is just use a sine wave. So the brightness goes like that, and then we just chop it off, right? So if it's below a certain level, then we kind of zero it out, so we get these like peaks. Could do something more fancy where we basically, the issue here is it limits how much control we have over the spacing of these. Like if we want a peak and then a long break and then a peak, like that's harder to do. So there are many ways to do this. I think a nice way is just to have a simple little equation for their brightness. So this thing called Wolfram Alpha is pretty cool in that it will graph stuff out for you. Okay, so here's like a sine wave, right? So how can I change the range? Next, from 0 to 60, let's say, if this is in seconds. Okay, that's probably okay. So let's say this should never be less than 0. So we can do something like this. Straight away, that gives us some periodic stuff. How about, like, is this too fast? So you can just do sine x times 0.5 to like spread that out. You know, honestly, just something like that may work out just fine. Have periods of kind of darkness and then spikes like this. Okay, maybe that's a good starting point. And if we want them to be tweak the shape more, then we can make that equation more complicated, but for now that's probably fine. So this probably means when we draw this, we're going to need a color, because that's effectively how we'll fade it in and out, and how we'll also, we can tint them a different color if we want. Okay, so now every time we draw things, we need to give them a color. This is just white, which is fine for the sort of environment layers. Then here, so let's figure out the brightness, right? So it's going to be, so we need to get the time. We can probably just use the time since the whole program started, which is the number of millis divided by 1000. So that's our x, if you like, and then we can use this same formula here. So that's the number of seconds which have elapsed. So the brightness is going to be something like that. Now the color is going to be, so if I want to make these green, for example, so red is 0, green is 255, blue is 0. The alpha, or the like opacity, is going to be basically just this. Now we have a color. So when we draw it, we tell it which image to use, we tell it the position, and we give it a color. Now in here, when we actually draw everything, just need to make sure to tint. I'm not sure if it likes the color. bet it's going to want a... Okay, maybe that works. I think I might have to say... Processing has a kind of weird way of packing color information in. Let's try this, see what this gets us. So everything's off, everything comes back in. Yeah, there's definitely way too much like off time here, so I kind of want to speed this up. So like maybe quite a lot. It'd be nice if they stayed up for longer actually, so let's figure out how we can make that happen. So we had what? So max of 0 and sine of x times 2. Okay, so we've got this kind of pattern. Let me just zoom in a bit. So what we really want is for them to maybe stay up for longer, so we could do something like we could, for example, square that, perhaps. Funky stuff with squaring things here. Oh. Yeah. So I got my brackets a bit wrong there. Okay, that's maybe a bit nicer, so they have more of a rounded kind of peak. We could tweak that even more, changing that power. Cool, let's go for something like this. Somewhat annoyingly, we can't just use the regular like power notation like that. We need to do it this kind of way. Some funky type stuff going on there. There we go. Maybe that's a bit too extreme and a bit too fast. Okay, so that kind of gives us what we want. The issue now is that our Fireflies are like all totally in sync, so what would be nice, or in phase I suppose is the kind of terminology you'd actually use here. So one way around that is we can just throw some phase here, and then each thing can kind of have a random offset into this little timeline cycle thing we got going on. So we can maybe just say random between 0 and 10, it really doesn't matter. Now we have our Fireflies kind of randomly pulsing themselves around. I feel like they're a bit fast now. Pretty cool scene happening here. So the last thing I want to do perhaps is to, don't know whether I should be doing this now, but I think it'd be kind of cool, is to throw in some a bit more advanced kind of lighting stuff here. So first thing we could maybe do is draw these in a kind of additive blend, if that makes sense. It is pretty pretty. I think it would be cooler if these were like illuminating the environment in a bit more of a direct way. So one way is we can use a blend mode here. And this is exactly the same thing as in my image editor. I can kind of set the mode of these layers, if you're familiar with that kind of stuff. What we probably want to use is additive blend, which means that when two things are on top of each other, their brightness will kind of stack up and it will get like even brighter basically. Yeah. Thinking about it now, that also eliminates a lot of these issues with sorting. Okay, that's good. So, you know what, let's give this 2 versions for convenience. A basic one and a more fancy one. Okay. Yep, go ahead. Always open to new ideas. Sonic Pie. I'm not familiar with Sonic Pie. Oh, okay. So it's like a music. Oh yeah, or maybe I'll look into that. So it's about using coding to make some kind of musical system, something like that. It's pretty cool. What's happening here? Ah. I'm not super musical, in terms of music theory type stuff especially. Okay, so maybe we can't see the effect immediately about this blend. I mean, we have other people on the team who are like very musical, so that's totally something we could look into. And Paul, our musician, knows how to code as well, so maybe there's something there. So I figure it's not super obvious what this blend mode stuff is doing, so I may put an absurd amount of fireflies here for a second, just so we can see the effect of that. If this crashes my PC, then goodbye. Okay, even here it's not super obvious. It's actually running surprisingly fast. Do we add 10 times more fireflies? Yes, we do. It is. Okay, you can kind of see here now when there's lots of fireflies, they're brighter than any like single firefly, if that makes sense. What's my frame rate? 14 frames per second. Okay. Let's cut that back for now. One thing I might do is make these a bit bigger, or even just make their glow a bit more intense. That could be cool. Yeah, that's kind of nicer. Whoa, yeah. We got something happening now. Okay, so the last thing I want to do is have these actually apply some lighting to the scene. Which is kind of something we do in Steamhound, which I really like. So I think I'm going to make them a bit bigger. Center this guy. Then we can amp that up a bunch, which should hopefully give us a bigger kind of area of effect on these. Okay. What I might do is also what if they vary in size? That's a cool idea, actually. Yeah, I kind of really like that. So one way to do that is we could scale them based on their distance, which might not be a terrible idea anyway. Just adding a bunch of junk into here now, but I'm okay with that. So let's map them from Third, map it from depth. Do that from what I'm doing here is not generally good, which is just throwing a load of junk into this thing is becoming like a kitchen sink, but in terms of getting stuff working quickly, this will do something for us. Oh, I wasn't even applying the scale here, so where are we? Okay, this is pretty cool. Kind of feeling atmospheric now. So what I'm playing around with is trying to get the aura to kind of look how I want. What I was really after is a kind of whitey green aura. It's there we go. Okay, that's nice. And now what I want to play around with is have these, rather than just adding light into the scene, have them actually like kind of reveal this scene underneath, if that makes sense. So we're going to make it even darker and have these like illuminate things. So stream is supposed to be short. It's not super short right now, but we shall figure that out. So okay, so there's an approach to doing this, and this is kind of how we do a lot of the lighting in Steamhounds actually. So revealing some trade secrets here perhaps, but it goes something like this. Let me, you know what, I don't need to keep all of these around. So we've got this deal here, right? And we have, say, Firefly over the top. Right now, the way it's working is this has an additive blend, which means that when two of these get together, their lights kind of combine, as opposed to a normal blend where it never gets any brighter than like the base image, if you like. So we have these things now, kind of around the scene, and this is kind of what we're doing right now. How many lines of code does Steam have? It's in the tens of thousands. I want to say like 70,000, maybe. Depends what you count, because you have like text files which aren't exactly code, but and it's not necessarily a good thing that it has so many. Like, if I was to do the whole thing again today, I could probably do it with fewer, which would kind of be better, but it's like 50 to 100,000 probably somewhere. Okay, so there's our kind of current setup, and that's kind of what we're doing right now. What I think would be cool is to have something where the whole scene has like a dark lighting kind of applied to it. Purple seems to be the color that's appropriate here. Right, kind of like this, which gets multiplied over the top, so you can kind of see that it's like masking out and making a kind of nighttime effect. And again, rather than just putting these over the top, what I'd kind of like to do is, yeah, the same kind of deal we have in Steamhounds, where it's kind of hard to explain, but basically what you do is you add these guys on top of the kind of lighting layer. And then this whole lighting layer gets kind of multiplied on top of the scene behind it. So it may not be super clear, but you can kind of have these things. Basically the Firefly is kind of revealing what's behind them, if that makes sense. So, you know, I can move this around and I'm kind of revealing the scene underneath, which just gives a more kind of accurate sense of, you know, it's a bit more realistic to us, like actually illuminating the scene as opposed to just kind of being slapped on top of it. And I definitely need to tweak the brightness here to make this work as we'd like it to. Yeah, but that's kind of something I maybe want to try here. And the way to do this is we need a kind of need to do this in two passes. So we need to kind of draw our lighting, if you like, to one layer, and then draw our kind of blend that on top of the scene. So I'm looking for a way to draw stuff to a kind of to like a temporary texture, essentially. P graphics, I think that's what I want. Yep. So what I'm going to do here is hello, sick boy. Not exactly. So I'm using processing for like little kind of side projects and things like that. So sometimes we do a mini game on stream. The idea is each week we pick a totally new project and kind of build that from scratch. So what we're doing right now is that we've got this kind of parallaxy forest environment, and we are drawing some fireflies kind of on top of this. So we've been working on this parallax effect. We've also got the movement pattern and the kind of flashing on and off kind of thing going for these fireflies. Yeah, so processing code for like a small project or like a mini game. Awesome, sick boy. Thanks for the follow. It does look cool. Maybe I should just leave it here. This whole other little side tangent I'm going on is maybe unnecessary, but how long have we been streaming? Not too long, like 2.5 hours. I'll maybe go another 15 minutes or so with this. So this is nice, and I'm just trying to tweak this so that the way the lighting from these fireflies interacts with the environment could be made a little bit more cool looking, I think, because everything still has a kind of flat appearance to it in a sense. So what I would need to do is create our separate little lighting layer here. Yeah, I do kind of think that the parallax stuff is a bit like intense. So we could probably tweak that to be like yeah, that's a bit nice. In fact, even that's kind of fast. Yeah, it's a bit nicer to me. A bit more sedate. It's supposed to be a calming kind of scene, after all. So our fireflies are moving around. We're going to do this whole lighting deal. So I need to make sure I do this correctly. So I think all we need to do is okay. I'm just going to tag this with a type. Then I think what I want to do is, yeah, okay. So, okay. So another thing I kind of want to account for here is if a firefly is behind a tree, it's obviously not applying any light to anything. So in figuring out this kind of lighting mask, if you like, the tree should like effectively totally black out these fireflies behind them. So I kind of need to draw them in black over the top to kind of handle that essentially. So if I'm drawing a firefly, I draw it in normal, its regular color. Otherwise, if it's a scenery, then I kind of just want to tint the thing black. I also want to start it out black. Yep. Okay, let me draw the thing. Everything here needs to be specifically done. That different layer. Okay, then I also want to kind of fill it with a lighting color, if you like. So let's move this up here, like the ambient light color, which can be kind of a dark bluey purpley. So like 40, 10, 90, let's say, round that off. Which is equivalent to this. I don't know if you can see my layers here. This kind of basic purpley lighting thing we got going on. Okay. Now we've done that, we can do something like, well, we can just draw the lighting layer. Probably got some offsets wrong here. Ah. Okay, we can see our things kind of being drawn there. What? Yeah, I've been okay. So trying to get these things to blend on top of each other, I was kind of. This is kind of getting a bit messy. I'm kind of regretting trying to do this right at the end of the stream. But what I've done essentially is yeah, I've kind of laid these things up a little bit wrong, which I should be able to sort out. Okay, we're now seeing what I had hoped to see, just slightly off. Okay, so let's check this out again, and hopefully I can now explain what the hell I just spent the last 5 or 10 minutes doing. There's totally something weird going on with these things here. Okay, we're kind of seeing what I hoped here. So I don't know if you can kind of tell, but as these things move behind the tree, they're getting cut off behind it. So there's our regular kind of scenery behind there. So what we've got here is essentially the lighting, which we then want to apply on top of our whole scene kind of separately. And why it was looking kind of crazy and weird is because, yeah, exactly. So rather than just drawing the fireflies on top of everything, it's about having the light from the fireflies actually like reveal the forest behind it, if that makes sense. So it's kind of like, yeah, as if we're like super in the dark kind of thing. So that's now getting drawn correctly. So what we can try and do is then kind of draw the regular stuff on top. Okay, so what I do here is get rid of a lot of this junk. Oop, that was unnecessary. So now I'm kind of restoring what I had before, where we draw our regular scene. So now we'll have two kind of layers which we can blend on top of each other. So if we take the okay, so Get rid of all this debug stuff from here, which we no longer want. Okay, I'm hoping this will allow me to demonstrate. Okay, so here's our regular old scene we had before. Ooh. Something weird with the blend mode. Okay, that's something weird happening there. So when you start using these blend mode functions, you get real issues when you don't like reset it to like the normal kind of blend mode. So you can. This is what I've seen look like before, and you can see something odd happening there. What is going on? This is why games have graphical glitches, because it's kind of awkward to keep track of all of this. Where are we? Whoa. Something kind of crazy going on. Ooh, okay, that's probably an issue. What's going on? So I'm seeing some kind of error down here. Oh, okay, I know what's happening. Okay. This was getting tinted. So the tint from one of the things we're drawing is kind of carrying over and tinting our whole lighting layer, which is not what we ideally wanted. I think I should see a black screen now, mostly. Cool. So when we draw this thing on top, we don't want any other stuff which is nearer to the kind of virtual camera to cut through. So I think that will. That's why we were seeing those weird square cutouts of things. Nope, still does not like that. Test. Yeah, this is probably a rabbit hole I should not have attempted to go down. Okay, we can finally draw something on top. That issue there, which hopefully means we can now that's not getting cleared, maybe. Okay, so now we're seeing our regular old background and our lighting layer, although for some reason the positions are not aligned, so that's something we can deal with. So this is our regular scene. Here's our lighting thing where you can see the trees, kind of things going behind these trees as we would expect, and then we can try and like blend these on top of each other for a more interesting kind of lighting effect in the scene. So what's going on with that being off? Oh, I know. We're probably not using the same author function. Okay, this is almost what I was going for, but I think we've still got something where their positions are kind of offset, because these two layers are not like aligning properly. Hopefully kind of getting the general impression of how these fireflies are now kind of illuminating, like punching through this scene, but they're just not quite lined up with each other. Going to drop down the number of fireflies so I can figure out exactly what the relationship between these two layers is. Right. Oh, okay. I know what this is. So basically we're doing using something called image mode. Make sure we're kind of centered. We should do the exact same thing to the lighting layer. So everything on the lighting layer is being drawn sort of in relation to the corner of things as opposed to the center. Which is a problem. I should probably only call this after I've done git draw. Okay, let's put our 100 fireflies back. Let's see where this gets us. Apply then normal. Okay, whew, okay. We are there, finally. So I think the last thing to do now is probably just tweak some of these color values a bit. You may not be able to see on the stream because things are pretty dark, but we are actually kind of revealing this little nighttime scene behind here. So there's a couple of reasons why this is super dark. I think the main one is that the scene is already kind of drawn in like a nighttime color palette. Everything's kind of fairly dark anyway. So what I'd probably need to do is to open these up and just amp up the brightness and saturation of these. So it's way up like that. Maybe we're going to look super crazy, but we shall see. Same thing here. Here. This also might not work because this has already been shifted to be really blue, like presumably for that nighttime look. So I'm kind of doubling up on that effect as well. One quite cool thing with this is we can tweak this color, this kind of lighting color in real time. Did not like this for some reason. Cool. Didn't get quite to where I hoped it would, but this allows me to kind of play with the lighting in the scene. Cool. Okay, this is kind of fun, but it's getting kind of late. I think this is probably a good place to call it. We have our little parallaxy Firefly scene going on here. It looks kind of cool. I don't know if the lighting thing I was playing around with there helped or made it look worse. Probably the latter. But sometimes you just got to go down a rabbit hole for the fun of it. So thanks everyone for watching. I will sign off. If you keep an eye out in our Discord or Twitter, then you'll see when I post the VOD, and that will include the whole source code for this, which I'll probably clean up a little bit before posting. Yeah, but thanks everyone for tuning in. Take care, and I will see you next time.